All right, let's dive in. Today, we're not just talking about AI that lives somewhere up in the cloud. Nope, we are going to build an intelligent physical machine right from the ground up, piece by piece. So let's get started.
I mean, just think about that for a second. An AI that doesn't just crunch data, but can actually, walk through a crowded room, open a door for you, or maybe even help out around the house. That right there is the incredible promise of physical AI, and it's the big question we're really digging into today.
Every great project, every great creation, it all starts with a solid blueprint, right? So that's where we're going to start, with the absolute foundations of what physical AI even is.
So at its heart, we're talking about something called embodied intelligence. Think of it like this. It's the difference between an AI that can describe a cat to you and an AI that can physically reach out and pick that cat up. Gently, of course. This is really where the code meets the real, messy, physical world we all live in. Okay, so we've got our blueprint. Now it's time to actually give our AI a body. But, well, a body's pretty useless if it can't move, which brings us perfectly to our second module, how do we master locomotion and control? And let me tell you, this is a huge challenge. I mean, it's one thing to get a robot arm to move in a factory, where everything is perfectly controlled and predictable. It is a whole other ballgame to get a robot to walk across, say, a rocky path or a slippery floor without just toppling over. And I think this comparison is just fascinating. For us, learning to walk, it's just trial and error as a baby, right? It becomes second nature. But for a robot, it has to achieve that same effortless stability through a constant, massive stream of data and unbelievably complex calculations for every single step. And this process is not a one-and-done thing. It's a continuous loop, happening at lightning speed. The robot senses the world around it, calculates all the tiny adjustments it needs for balance, makes the move, and then immediately learns from the result to do it better the next time. It's a constant cycle of sense, think, act, adapt. So our AI can walk. That's amazing. But walking blind isn't exactly helpful. To be truly intelligent, it needs to be able to perceive and actually understand the world. And that brings us to our third module, giving our AI senses.
And this is where we really start to move from just pure mechanics to something that feels a whole lot more like genuine intelligence. How do you give a machine the power to not just see a bunch of pixels, but to actually recognize a human face, to not just register sound waves, but to understand a question you're asking it?
Well, here's kind of how these robotic senses mirror our own. For sight, you've got cameras and LiDAR, which is kind of like radar, but it uses lasers to paint a 3D map of a room. For hearing, pretty simple, microphones. And for touch, you've got tactile sensors that can actually feel pressure. This is what allows a robot to know exactly how hard to grip something like an egg without, crushing it.
Okay, we've built a machine that can move and perceive. We are so close. But now we get to what might just be the most important module of all, getting this thing ready to safely and effectively live and work right alongside us humans.
This quote really just gets to the heart of it, doesn't it? This kind of technology isn't built in a vacuum. As these incredibly capable systems start to enter our homes, our workplaces, our public spaces, we have to decide on the rules of engagement before they show up. And you have to realize this isn't just a technical question about code and wires anymore. No, this is a deeply, deeply human one. How do we build trust with these things? How do we absolutely guarantee safety? And how do we make sure these machines operate in a way that aligns with our values? So it really boils down to these three critical pillars. First, there's human-robot interaction, or HRI. That's all about creating an intuitive, easy way for us to work together. Then you have safety protocols. These are the absolute non-negotiables to prevent any kind of harm. And then, maybe the most complex piece of all, are the ethical frameworks, actually programming a machine to navigate all those moral gray areas. So when you put it all together, what we've really done is construct our physical AI on top of four deeply interconnected pillars. So let's just recap those four building blocks. You need a solid foundation. You need a body that can achieve locomotion. You need a mind that has perception. And critically, you need an ethical framework to guide its interaction with our world. And that really is the ultimate question we're left with. As we engineer these absolutely incredible machines, the most important and lasting component we build into them won't be made of silicon or steel. It'll be made of our own humanity.
What's that going to look like?